Hello everyone! Ever wondered how scientists can look deep inside a material, down to the level of individual atoms? Today, we're exploring a powerful technique that does just that, called X-ray Absorption Spectroscopy, or XAS for short. In simple terms, XAS is a way to find out what atoms are in a sample and who their neighbors are. It works by shooting a beam of high-energy X-rays at a material and measuring how many of those X-rays get absorbed. The key is that we can precisely control, or tune, the energy of these X-rays. For most energies, the X-rays just fly right through the sample. But when the X-ray has the exact right amount of energy, it can knock an electron out of its deep, inner shell in an atom. At this specific energy, called the absorption edge, the atom suddenly starts absorbing a lot more X-rays. This creates a sharp jump on our data graph, and the exact energy where this jump happens is like a fingerprint. It tells us exactly which element we are looking at, whether it's iron, copper, or nickel. But there's more. The region right around this jump, which we call XANES, also tells us about the element's chemical state, like its charge. After the main jump, we see a series of smaller wiggles in the data. This part is called EXAFS. These wiggles are caused by the electron that was just kicked out. As it travels, it bounces off neighboring atoms, and this interference pattern tells us an incredible amount of information. By analyzing these wiggles, we can determine what the neighboring atoms are, exactly how far away they are, and even how many neighbors a specific atom has. It gives us a complete picture of the local atomic environment. Because this technique requires very bright and tunable X-rays, experiments are usually done at huge facilities called synchrotrons. Scientists use XAS to solve all sorts of problems, from designing better batteries and more efficient catalysts to studying how pollutants behave in the environment. It's a truly versatile tool for understanding the invisible world that makes up everything around us. Thank you so much for watching. If you found this explanation helpful and want to learn more about the fascinating tools of science, please consider liking this video, subscribing, or supporting the channel through the links in the description. Your support makes these videos possible and is greatly appreciated.